Hello everybody, this is Miguel Hernandez, and I will be breaking down problem number 90. Problem number 90 states, in the real numbers with the usual metric, does the sequence -1 to the n over n flirt with 0? Before we start the proof, the answer to the question is no, this is not. So we will be proving this by contradiction. So the proof states as follows. We will let the sequence -1 to the n over n be a sequence in the real numbers, and our distance will be the usual metric. We want to show that the sequence -1 to the n over n does not flirt with 0. So we will assume towards this contradiction that the sequence -1 to the n over n flirts with 0. Then if this is what we're assuming, then we want to show that the sequence of -1 to the n over n flirts with 0 if and only if for each epsilon greater than 0 there is an n in the natural numbers and there is an m greater than n such that 0 is less than the distance Pn and the distance is less than epsilon. And we have to show that the distance in terms of Pn is less than the distance in terms of Pm. Then for all epsilon greater than 0, there exists an n and m in the natural numbers such that n is less than m, and the two following conditions must hold. So the first part of this problem states that 0 is less than the absolute value of -1 to the n over n minus 0, and that is less than epsilon. Since the absolute value makes everything positive, we get that 0 is less than 1 over n, and 1 over n is less than epsilon, which is true. Now the second part states that the absolute value of -1 to the n over n minus 0 is less than the absolute value of -1 to the m over m minus 0. And again, since this is the absolute value of both of these distances, because we are using the usual metric, this implies that 1 over n is less than 1 over m. But that is a contradiction. That is a contradiction since we assumed that m is greater than n. And m greater than m, the n implies that 1 over n should be greater than 1 over m. Hence, the sequence -1 to the n over n does not flirt with 0. That is the end of the proof. Thank you very much.